and we're specifically talking about these pieces. For example, the equation was nothing new, right? Y equals a times x minus h quantity squared plus k, and the horizontal was x equals a times y minus h quantity squared plus k. And we talked about the vertex being hk in both situations. And we talked about the axis of symmetry being a vertical line through h, and here the axis of symmetry being a horizontal line through k. Oh, I wrote the same thing. I'm sorry. Thank you. Y minus k quantity squared plus h. Okay. So then these other pieces that we talk about are like the focus and the directrix and the length of the lattice rectum and those pieces. So what happens is, as I draw my parabola, this point is a vertex, which you're familiar with, but the focus sits on the inside and the directrix is a line that sits on the outside. And the distance from the vertex to the focus is p units. Did we mention p yesterday? Okay, the problem is you don't know what p is. Well, p we find from an equation. And the equation is a, or a being the number in front, so the coefficient, a happens to be equal to 1 over 4p. So that's an equation that you have to know. Again, do you get your notes or do I make your notes for the test? You make your notes, okay, Sunshine Man. All right. So if this focus is p units from the vertex, do I move vertically or horizontally? Vertically. So is that going to affect the h value or the k value? It's going to affect the k value. So the focus is h and then k plus p. But the directrix is an equation for a line. And a horizontal line has an equation of x equals or y equals. Horizontal line, y equals. Y equals, and what is it? It's your k value minus p. So that's what we have to do there. We talked about direction of opening yesterday, right? If A is positive, it goes. If A is negative, it goes down. Now, let's talk about the horizontal parabola here. Again, you have a vertex, and then you have a focus point, and you have a directrix. And again, the focus point sits p units from the vertex, and the directrix sits p units from the vertex. So if I can move from the vertex for the focus, do I move horizontally or vertically? Horizontally. Is that going to affect the h value or the k value? It's going to affect the h value. So it'll be h plus p, whatever the k value is. And then the directrix, that's a vertical line. So is that x equals or y equals? X equals. And the x value, we're going to take the h value, instead of add p, we will minus p. And we also said if a is positive, it's going to go to the right, and if a is negative, it goes to the left. Okay. So the last part we have is the length of the lattice rectum. We got we got the issue with saying that yesterday, right? So we talked about our good friend on previous classes who laughed every time that word came up, right? We didn't? Oh. That was the other class. By the way, so the word rectum is Latin for segment. And so, you know, if you think of our biology, it is. It's a segment. It handles some nasty business, right? Okay, that's just what it is. So length of the lattice rectum happens to be the absolute value of 4p. And you're like, well, what the heck is it? It's a segment. It's a segment that goes through the focus. And it shows us how wide to make the parabola. So now I'll be able to draw a perfect parabola. So we got a lot of notes on the front here, and I don't know how you kind of want to work through them, but you know, if you want the formulas, that's what they are. But I don't think it's that complicated when we actually go through and graph this stuff. So we're going to do an example now. We're going to try to simplify this process. You ready to make it simpler? Let's make it simpler. Yes, Mr. Gens. Thank you, Mr. Gens. Let's do this, Mr. Gens. Okay. So We got 4 problems to do, and then you get time to work today, probably about 10 minutes. This is y equals 1/8 x plus 2 quantity squared plus 3. Identify all characteristics. So we're going to do the direction. We're going to do the vertex. We're going to do the axis of symmetry. We're going to find our p-value. We're going to find our focus. We're going to find our directrix. And we'll find the length of the lattice rectum. And on the test, for a portion of it, I will list all that information for you so you don't have to continue to write it down all the time. Fair enough? Fair enough. Elena, I like your mock trial shirt. Looks very Albert Lee-ish. Okay, got it written down? Horizontal or vertical? Vertical, why? Because it's y equals. Very good. So it's vertical. Is it going to be up or down? Up. How come? Positive. Awesome. We got the first part. Vertex. What's the horizontal shift? Left 2. So you see x plus 2, so it's left 2. Vertical shift? Up 3. At this point, I start sketching the graph. Some of you will try to list all this stuff. I get students who list it all, and then they're like, I don't know how to sketch a graph. As you list it, start to sketch it. So that's the easier way to kind of manage this process. So I got my x and y axis, and I'm going to make this an 8 by 8 graph. Because I'm going to try to draw a perfect parabola. I'm going to be very careful. And you might not care if you draw a perfect parabola, but I am trying to impress you today. I know I impress you every day, but we're going to see what happens here. Okay, so -2, +3. So I go back 2, and I go up 3. Everybody okay with that? So is the axis of symmetry going to be a vertical line or a horizontal line? The direction is up, so it's going to have to be a vertical line that splits in half. So instead of trying to figure out what the axis of symmetry is, I just draw it, and then I name it. That's a vertical line. So it's x equals, and what's the x value passes through? So see how I didn't look at the front for what the equation was. I just did it. I had the 3 basic components we've always been able to do. Now I identify the p-value. In order to identify p, I say a is equal to 1 over 4p, or 1/8 is equal to 1 over 4p. Can you just look at this and identify what p is? Yeah, p is 2. So if p is 2, what that means is I move 2 units for the focus and the directrix. I move 2 units. It's positive, so I move 2 units up. 1, 2. That's my focus point. Did I have to look back at my notes? No. What's the location of that coordinate? -2, 5. Sweet. Now I'm going to move 2 units in the other direction. It's not a coordinate. It's a line that runs perpendicular to the axis of symmetry that goes through that y value, a y value of 1. If you write -2, 1, I will not give you credit on the test. The directrix is an equation for a line. It must be y equals or x equals. Are we clear? Okay. So now I have the length of the lattice rectum. This is the best part. The length of the lattice rectum is the absolute value of 4p, which is going to be 8. So if it's 8 units wide and the focus sits in the middle, how many units on each side of the focus point? 4. So it's 8 units wide. So when I go to the focus point, I'm going to go 4 units on each side. Yo. Sure you do. All right. So that's my lattice rectum. Total of 8 units wide. That tells me how wide to draw my parabola. So I start at my vertex, and I head up through the endpoints of the lattice rectum. Now, what's cool is that before you always wondered, how wide do we make the parabola? You don't really know until you start doing this. Now you know how wide to make it. And now we get to the challenge to see if I drew a perfect parabola. Are you ready? I'll show you how I determine whether or not it's perfect. I go back to the definition. What we wrote down yesterday is it says the parabola is a set of all points. So a point whose distance from the directrix and whose distance from the focus are the same. Do those look to be the same? We'll check here because I hope it's right on. We'll see. Okay, I'll tilt it, and then I'm going to drag it over here. And what do you think? Oh, I'm going to do better. I promise you guys, I'm going to do better. I'm off, aren't I? I know, I'm off. I'm off. I know. First, it was right on. It was, you guys were impressed. Like, standing ovation. Not really, but it was cool. Okay, let's try next one. I'm going to do better this time. Okay. Challenge accepted. Okay, Carter, A+. Carter, you just said something. Say it out loud. Thank you for saying that, because in order to be successful, you got to do what first hour did. And that is, we had to stop class about 6 times to say, how did you get that? Where did you get that? If you guys just nod through this whole lesson, you're not going to do well on the test. Trust me. You got to tell me where you get confused, because everything that is below the axis of symmetry, it's all new, right? And that's what every day is going to be this semester. New material. So when you get confused, you got to ask that question. So we start. I got to put in a form that I understand. Should this be an x equals or a y equals? What do you think? It's going to be an x equals. How come? The y is squared. So if I divide by 2, I get x equals 1 over 2 y squared. So I have a direction. I have a vertex. I have an axis of symmetry, a p-value, focus, directrix, and length of lattice rectum. Horizontal or vertical? Horizontal. Left or right? Right. Anybody confused about how we came up with that? X equals means that it's going to be horizontal, whereas Y equals means it's going to be vertical. Once we determine horizontal, positive, right, negative, left. Good question. Vertex. This one was shifted left 2, up 3. Is this one shifted at all? So what's the vertex? 0, 0. I'm going to start putting some information down on a graph. I'm going to do a really good job making my graph. I want to draw a perfect parabola. That's not very good, Kevin. Oh. I have tendencies, and one tendency is I always make the left axis longer than the right, probably because I'm standing on that side. But I've got to improve. Okay, so I'm going to plot the vertex. It sits at 0, 0, and it goes to the right. So will the axis of symmetry run horizontally or vertically? Horizontally, because it's opening to the right. And so it's going to go right through the middle of it. So that's a horizontal line. Horizontal lines have equations of y equals what? 0. Sweet. So here is where we get to where Carter says, hey, I need some help there, right? We always start by finding the p-value. What's our equation to find p? A equals 1 over 4p. So what is our A value? 1/2 equals 1 over 4p. If you can't see what, can anybody see what p is? It's a half. If you can't see it's a half, cross multiply. 4p is equal to 2. P is equal to 2 over 4, or 1/2. Every time you have to use that equation. Yeah? I use that p-value in order to determine these three. You got a picture. It opens to the right. The focus sits on the inside. How many units from the vertex does it sit? Whatever p is. So I move a half a unit in, and I move a half a unit out. The half of the unit on the outside is the directrix. The half of the unit on the inside is the focus. So that focus is what? What's the location? 1/2, 0. Good. Directrix is a vertical line. So Carter, is this clear now? Find P, move inside and outside and write them down. Length of the lattice rectum, that's where it gets fun. Absolute value of 1 over, or absolute value of 4p. Multiply this by 4 and you get 2. Well, if I want a segment of 2, I should move how far in each direction? 1. Okay, again, it's opening to the right. So I'm going to go 1 unit up and 1 unit down. Oh, not very good. Better. Okay, so that's my lattice rectum, and I'm now going to take that and I'm going to use it to be able to sketch my perfect parabola. I want to test to see if it's perfect, so I'll put a point on there. You don't have to do this. I just do it because it's fun. And I'm going to see this distance. I'm going to see this distance. And I'm going to check. Oh! Still off, huh? Now, I know in all fairness, I extended a little bit further there. That's a lot closer, isn't it? I mean, that's respectable. But I've never had a class where I haven't gotten it closer than that. So I did. No, I'm saying like in a year where I've taught 2 or 3 classes, I've eventually been able to get it in all the classes. You know what I mean? So we're gonna do one more. I got one more shot. You guys are gonna set this one up here pretty much on your own. But I wrote the problem incorrectly. Instead of a +1, it's 12x plus 12. And so I'm going to help you get the equation in the vertex, and then you're going to take it from there, okay? So first of all, when we solve here, do you think we solve for x equals or y equals? We solve for x because the y is being squared. So 12x is equal to y minus 2 squared minus 12. Then what? Divide by 12 or multiply by 1/12. We get x is equal to, I'm not going to write y minus 2 quantity squared over 12. I'm going to write as 1/12 times y minus 2 quantity squared. That way I can see my a value a little bit more easily. I have to divide the 12 by 12 and I get 1. So as you kind of work through this, the two I want to help you identify right away are the direction and the vertex. This is where people make mistakes. Is this going to open horizontally or vertically? Horizontally, left or right? Right. I'm going to ask you what the vertex is, but I don't want you to answer right away. I'm going to pause for 5 seconds, let everybody think about it, come to an idea, and then I'll ask again. What is the vertex? Okay. What do you think is the vertex? Two, -1. Other ideas? Okay. So you remember when I first wrote the notes down today, and you guys, oh, you switched up the h and the k value. Look, it says y minus 2. See how the 2 is paired with the y? That means that this is the vertical shift, not the horizontal shift. Remember back in the notes when we wrote these down? It's HK. Here, H is on the inside. Here, H is on the outside. You see that? So you got to be careful when it's horizontal. You got to switch your H and K values. You try to see the rest through. Come up with the pieces and then try to sketch the graph. Okay? Yo. We switched it to 12 because if it's 1, it doesn't work out very well. I just forget to change the notes. Okay, I'm going to start putting it down so you guys can check your answer. But the axis symmetry should be y is equal to 2. The p-value is 3. The focus sits 3 units towards the inside. That location of the focus should be 2, 2. Any question how I came up with 2, 2? Then I move 3 units to the other side, 1, 2, 3, and that's my directrix. That has an equation of x is equal to -4. The length of the lattice rectum is 12. So I got to move 4 units, I'm sorry, 6 units on each side of the focus. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And come on, Gens. All right, what do you think? Think I got it? The inside one is longer, isn't it? Gosh, it's usually the other way for me. I mean, it's close, but you're right. It's still not quite as impressive as what it should be. No, I know what you're saying. I know what you're saying. Right now, I'm calibrated. Like, as far as it's calibrated a little bit too far that way is what's happening to me. I know that. Yeah. See, people who were in first hour aren't used to how much you mouth off to me. They're just not used to that. All right, last example. Let's do some fractions. I guess I get one more chance to redeem myself. I feel bad. In 3, I really haven't drawn a perfect one yet. Do I solve y equals or x equals? Y equals. So I got y is equal to, or 7y is equal to negative 4x squared. So y equals negative 4 over 7x squared. So I have direction, I have vertex, axis of symmetry, p-value, focus, directrix, and the length of the last rectangle. On Monday when we do ellipses, there's a lot less stuff to write down, and they're easier. I think the parabolas are the hardest ones. Direction, down. Y equals, so it's vertical. Negative, so it's down. Vertex, 0, 0. So today we've done 2 that are shifted, and we've done 2 where they're centered at 0, 0. So I'll make a graph. Make a 3 by 3 graph here. I plot 0, 0. So the axis of symmetry, vertical or horizontal? Vertical. X equals 0. Mr. Johnsrud already found the p-value, which was? So when you go to find the p-value, you can see that you take a, which is negative 4 over 7 is equal to 1 over 4p. And in order to solve that, you cross multiply and get negative 16p is equal to 7. Divide by 16p is negative 7/16. So because p is negative, that just means that when we go to find the focus, instead of moving up, we move down. So it should match with the indication of what the arrow is. So if the direction is down, then the p-value should bring you down. If it's to the left, it should be negative as well. So if I move negative 7/16, how much is negative 7/16 approximately? It's about a half, okay? So a little bit less than a half. So try to move a half a unit down. What's that location? Yeah, 0, negative 7/16. If I move negative 7/16 up and draw my line, what's the equation for that directrix? Is it a y equals or an x equals? Y equals 7/16. Thank you. Length of the lattice rectum. Absolute value of 4 times 7 over 16. If you multiply 4 over 16, that reduces to 7 over 4, right? We got 7 over 4. So 7 over 4, what's half of 7 over 4? 7 over 4 multiplied by 1/2. And this is the same thing we laughed about all first hour. They said 3.5 fourths. And you're absolutely right. It's the right idea to think about 3.5 fourths, which is the same thing as 7 over 8, right? Multiply top divided by 2. 7/8, right? No, you're not stupid. Everybody said the same thing. So I'll move 7/8 in each direction, or 3.5 fourths, okay? Which is almost 1, but not quite. So if I move 3.5 fourths, or 7/8 in each direction, or here, here. So I've plotted my lattice rectum. I'm now going to sketch my graph. And this one is more narrow than the others, so it's really hard to make sure that it's exact. Well, I don't have my hopes up, but we'll try. Well, just that I'm bad at everything. Wish I wasn't bad at everything. Oh, hey, that's pretty good, huh? Get your box away. Um, that's that's pretty good. All right, I'll take that. All right, we'll count it. All right, so here's your assignment. I want you to know that I've cut this assignment down over the years. This used to be longer. And how your book chooses to address this is your book says, hey, we're going to do ellipses, parabolas, and hyperbolas all centered at 0, 0. And then in 9.4, we're in one lesson, we'll address all of them as they're shifted. I say no. 9.1 is the parabolas centered at 0, 0. 9.4 is the parabolas where they are shifted. So we'll address parabolas on one day as opposed to, do a little bit of each altogether. So that's just the way I've addressed it, okay? I think that this is going to help you. So the first 5 problems are centered at 0, 0. The next 3 problems are shifted. Especially second semester, I really do try to cut down on your problems and try to just ask those that are truly important. And I can't think of a problem up here that's not truly important to your understanding of this content. So if you can do parabolas, you can do hyperbolas and ellipses. I promise. After that, we do one more section. It's a little bit harder, but I believe in you. Okay? So, you got 10 minutes, 11 minutes. You could probably get a couple problems done if you get to it.